Okay, moving forward with the defining of the connector, and we have done an example of defining a pin for a three linkage system. Now, if you go to folder of spring connector, and this is, and open this file. Let's look at the problem and see what is asked. So essentially, we have a weighting scale that uh, this has a like a green part that is connected via spring to another hook type part, and this hook type part is going moving up and down into this blue part, and this is no rigid connection between them. The only connection of is between this green hook and this base, or this green base, via a spring. So some of the information is given for this problem. For example, spring stiffness is given as 105 kilonewton, and essentially it says that the pin connector here, which is this like a rod of this hook part, and this blue base or blue part as a pin connector, but is only translational, meaning that this green part can goes up and down and there is no rotation between them. And then this is a fixed hole, this would be fixed, and 250 kilonewton force applied downward via this hole, and we would like to know that what would be the distribution of that, and essentially doing some analysis. So we are going to open a spring connector SolidWorks file here. And as you will see, this part is fully given here. And let's select plane 4 here. This is a like a plane that we can find the cross section of that. So let's evaluate this model a little bit. You see that there is a small gap between this green rod and this blue part. There is no rigid part, meaning that this green can go up and down with the help of this spring that is being between this green part, this face, and the other face of the lower green part, and it's going to go up and down. Okay, so let's start a simulation. And even though that this file has a spring here, but in order to really study this model, if we like do traditional static analysis, the effect of the spring of this part would not be taken into the account. And SolidWorks just consider this as a solid object that they has to analyze. There is no compression or extension of this part would be taken into account, or essentially the stiffness of this part would be the missing item. So if you try to do a traditional static analysis of this assembly or this part, essentially the result would be wrong. So let's start a new study, and we are going to do static, and I call it uh, spring connector. Hit OK, and then the panel of the simulation would appear here. So we have three different parts that we have to define it. You'll see that all of the parts already has defined. And here's the part, we have to exclude this spring from our study, which would be here. So we don't care about this one, and then we are going to define a spring by using a connector. So we have to exclude this part. I right click on this part, and there is a command called exclude from analysis, and then it's temporarily would be disappear from this simulation. The rest of the parts has a alloy steel material that has been already assigned to those three parts. So we are good on the material assignment. Now we have to define a connection. So this assembly, as I explained, we have two connector that we have to define. First, there is a pin in between, and second would be a spring. Let's define pin since we have selected that. So in order to do that, I find it easier if I go to the cross-sectional view because I can select these faces easily. So I'm going to right click on the connector and go to pin. So first we are going to define a pin between these two. So we know that how is going to move up and down. So if I select this part with respect to this face and the other face, which would be here, and then we have to select no rotation. So we're going to select this one and then remove the no translation. So we wanted to have the translation between these two. Then its string data is required because we have this part here. We are not adding a new pin here. We just wanted to restrain the motion of these two parts together. So I hit OK, and then it would be defined a pin here. So the other part that we have to select is we have to define, so getting out of this view, I would like to define a spring. So I would right click on the connection and go to spring. There are three types of the springs, and essentially we can define a general compression and extension spring. So here we have to define the faces to spring to be defined. One of them would be this face, and the other part, the other face, would be here. And this is distributed, and the the total value of that. So instead of having it distributed, we have to select like a total. The total was 105,000 kilonewton meter. What's this? Let me see. Oh, that would be Newton meter, not kilonewton. Oh, a mistake here. So we do have this spring connector here has been defined. Now we have to define a fixture. Right click, go to fixed geometry, and I will select this face. Okay. And then I would have to apply compression 250 Newton here. Go to external load, force. Similar to what we have done there, we can first select these faces here, 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 and here. And I would select the direction. I would go after, which plane is that? Let's see. Plane one is like this plane. So this should be, and then we want it to be normal to that, and is 250 Newton. Check the direction is upward, so we reverse it, it would be downward. Okay. So we do have everything. Material, connectors has been defined, spring connector more importantly, and then forces. So going to create mesh, make it a little toward fine mesh, hit OK. So three individual parts that SolidWorks mesh them. Sounds good. And then we run the study here. Okay, so the excessive displacement, similar to that, we say no, should be good. Okay, so you will see that if I go to the displacement, you will see that this part is totally blue, it's not moving, and the only moving part is this, which is the one that we wanted, right? And then if I go and animate, you will see that this force is going to push that part down. Okay, So this is not the problem that we have to define if the pin is okay or not. This is was merely about like the effect of the spring. Now, the spring, if I go to the stress, you will see that there are some stress part that applies to this, and it's defined that how much. So if I want to know that how much displacement was the essentially major information here, you will see that the maximum displacement, which is this part, was going to compress 9.553 millimeters. So that's the max compression that this part may exercise. So you will see that how we have defined this the spring connector here. That was the good example of combination of a spring and the connector that we have defined here. We may added a like a different information about that, but if I go to stress, for example, you will see that the system would not fail. Everything is less than yield stress, yield strength. So should be good. That would be another example of how we can model the spring here. That's very similar to motion analysis that we had, but this is like more detailed and showing the distribution of the stress along these parts. So that was another example of combination of pin and a spring connector. In the next example, I would like to go to the bolt and how we can define the bolt and fasteners in our assembly. Till then, see you there.